Introduction.
Good morning, teacher.
Good morning, students. Today we learn organic chemistry.
Teacher, what is organic chemistry?
Organic chemistry is the branch of chemistry that involves the study of carbon and hydrogen containing compounds.
Teacher, how the carbon-carbon atoms are attached?
The carbon-carbon atoms are attached by single bond, double bond or triple bond, and the functional group present on the organic compound decides its chemical nature.
Teacher, what is functional group?
It is a group of atoms in an organic compound responsible for the chemical reactions of that compound. In this lesson, you will learn organic chemistry and some basic principles. Objectives. At the end of this lesson, you will be able to define tetravalency of carbon, describe formation of pi bond, represent organic compound through complete, condensed and bond line structural formulas, represent organic compound in 3D, classify organic compound, describe nomenclature of organic compound. Tetravalence of carbon, shapes of organic compounds. Organic chemistry is the study of hydrocarbons and other compounds regarded as derivatives of hydrocarbons. Some organic compounds may also contain elements like nitrogen, oxygen, sulfur, phosphorus, halogen, etc. besides carbon and hydrogen. The shapes of carbon compounds. A carbon atom has 4 electrons in its outermost shell, so it needs 4 more electrons to complete its octet. A carbon atom can complete its octet only by sharing its valence electrons with other atoms. As a result, carbon atom forms 4 covalent bonds by sharing valence electrons with other atoms. This is known as tetravalency of carbon. For example, methane, ethene, ethine. Carbon can participate in hybridization and form sp, sp2, sp3 hybrid orbitals. Hybridization also affects the bond length and bond enthalpy in organic compounds. The sp hybrid orbital has more s character and hence it is closer to nucleus and forms stronger bond than sp3 orbital. The sp2 hybrid orbital is an intermediate orbital between sp and sp3. Some characteristic features of pi bonds. Pi bond is formed by the overlapping of p orbitals on adjacent atoms. The p orbital should be parallel to each other and both perpendicular to the plane of the molecule. Pi bond inhibits the free rotation of carbon-carbon double bond. Pi bond provides the electron charge cloud in the molecules which have multiple bonds. Structural representations of organic compounds. Complete, condensed and bond line structural formulas. The structure of organic compounds can be represented by Lewis or dot structure, dash structure, condensed structure and bond line structures. The Lewis or dot structures can be simplified by using dash. Single dash represents single bond. For example, propane. Double dash represents double bond. For example, propene. Triple dash represents triple bond. For example, propyne. These structural representations are called complete structural formulas. Structural representations of organic compounds. In the condensed structural formula, each carbon atom is written separately and following each carbon atom, other atoms are listed that are bonded to that carbon atom. For example, complete structural formula. Its condensed structural formula can be written as bond line structures. In this, carbon and hydrogen atom are not shown, but only the bonds between the carbon-carbon atoms are shown in zigzag fashion. The atoms other than carbon and hydrogen are shown in the structure, and the terminals denote methyl group. For example, butyl chloride, propene, cyclohexane, diethyl ether, dimethylamine. Three-dimensional representation of organic molecules. Three-dimensional structures of organic molecule on paper can be represented by using solid and dashed wedge formula. The solid wedge represents a bond projecting from the paper towards the observer. The dashed wedge represents a bond away from observer. A simple line represents a bond that lies in the plane of paper. For example, methane. Classification of organic compounds. Organic compounds can be grouped into acyclic or open-chain compounds and cyclic or closed-chain or ring compounds. Cyclic compounds can be further divided into homocyclic or carbocyclic compounds and heterocyclic compounds. Homocyclic can be further divided into alicyclic and aromatic compounds. Aromatic compounds can be further divided into benzenoid and non-benzenoid compounds. Acyclic or open-chain compounds. Acyclic compounds are the open-chain structures, and they are also called as aliphatic compounds. Alicyclic or closed-chain or ring compounds. Alicyclic are the organic compounds in which 3 or more carbon atoms are linked together in a ring. Aromatic compounds. Aromatic compounds are the organic compounds which contain benzene ring and other ring compounds. Benzenoid aromatic compounds are benzene, naphthalene, toluene, indene, biphenyl, anthracene, phenanthracene, etc. Non-benzenoid aromatic compounds are tropylene, etc. Heterocyclic aromatic compounds. A heterocyclic compound is an organic compound in which 1 or more of the carbon atoms have been replaced by an atom other than carbon. Typical heteroatoms are nitrogen, oxygen and sulfur. Functional group. It is a specific group of atoms in a molecule responsible for the chemical reactions of that molecule. Homologous series. A homologous series may be defined as a series of structurally similar compounds, each member of which differs from preceding or succeeding member by one group, CH2. The members of the series are known as homologs. Nomenclature of organic compounds. Nomenclature is the system of naming of organic compounds. In the early stages of organic chemistry, the organic compounds were named from the source from which they were prepared. For example, the name acetic acid was derived from vinegar because the Latin word for vinegar is acetum. Methyl alcohol was named wood spirit as it was obtained from the destructive distillation of wood. These names of organic compounds are called common names or trivial names. The IUPAC system of nomenclature. IUPAC stands for International Union of Pure and Applied Chemistry. By using this system, we can give a systematic name to an organic compound. The systematic name of organic compound can be derived by identifying parent chain, functional group and branch chain. We also add prefixes and suffixes through which the parent name is used to get the actual name. IUPAC nomenclature of alkanes. Straight-chain hydrocarbons. The names of these compounds are based on their parent chain structure and their name ends with a suffix ANE. Branched-chain hydrocarbons. In this, small carbon chains are attached to carbon atoms of parent chain. These small carbon chains are called alkyl groups. To name branched chain hydrocarbon, the names of alkyl group attached to carbon atoms of parent chain prefix to the name of parent alkane. An alkyl group is formed from saturated hydrocarbon by removing one hydrogen atom from carbon. To name alkyl group, we substitute YL. Some abbreviations are used for alkyl group, such as Me for methyl, Et for ethyl. Alkyl can also have branched chain structures such as isopropyl, tert-butyl. Nomenclature of branched chain alkanes. The rules for naming are given below. First, we identify the longest chain of the carbon in the molecule. The carbon atoms in the parent chain are numbered. It helps to locate the carbon atoms with attached alkyl group. The numbering in the parent chain is done in such a way that the branched carbon atom gets the lowest possible numbers. That means the numbering in the given carbon chain is from left to right. After that, the names of the alkyl are prefixed to the names of the parent alkane. Thus, the name of the given organic compound is 3-ethyl 1-methyl heptane. Nomenclature of branched chain alkanes. If the substituent groups are similar, then the numbers are separated by comma and prefixes are used such as given below. If the two substituents are at the same position from both the ends, then the lower number is given to the carbon which comes first in the alphabetical listing. For example, 2-ethyl 5-methyl hexane. Some IUPAC common names are: common name is isopropyl, its IUPAC name is 1-methyl ethyl, and its structure is this. Common name is sec-butyl, its IUPAC name is 1-methyl propyl, and its structure is this. Common name is isobutyl, its IUPAC name is 2-methyl propyl, and its structure is this. Common name is tert-butyl, its IUPAC name is 1,1-dimethyl ethyl, and its structure is this. Common name is neopentyl, its IUPAC name is 2,2-dimethyl propyl, and its structure is this. Nomenclature of branched chain alkanes. To name the multi-substituted compound, the following rules must also be remembered. If there are two chains of equal number of carbons, then the chain which contains more number of side chains is selected. The numbering is done from the end which is nearest to the substituent. For example, the IUPAC name of the given compound is 4,2,2-dimethyl propyl octane. Cyclic compounds. The single-bonded monocyclic compounds are named by prefixing cyclo-straight chain alkane. For example, cyclobutane, cyclopentane, cyclohexane. Nomenclature of organic compounds having functional group S. Functional group defines the chemical reactive nature of organic molecule. In polyfunctional compounds, one functional group is chosen as principal functional group and the remaining are treated as substituents with appropriate prefixes. Some functional groups are given below in the table. Decreasing order of priority for some functional group is carboxylic acids, acid anhydrides, esters, acid chlorides, amides, nitriles, aldehydes, nitriles, aldehydes, ketones, alcohols, amines, alkenes, alkynes, halo, nitro, alkoxy, alkyl. For example, let us write the IUPAC name of the following organic compound. Here, the word root is BUT, but, and primary suffix is ANE, ane. There are two functional groups, ketone and alcohol. Ketone gets preference over alcohol group. Thus, the secondary suffix is 1. The prefixes are methyl and hydroxyl. Thus, the name is 3-hydroxy, 3-methyl-butane, 2,1. Nomenclature of substituted benzene compounds. To name the substituted benzene compounds, these compounds are named by attaching the name of the substituent as a prefix to the benzene. For example, bromobenzene, tert-butylbenzene, nitrobenzene. If more than one substituent is attached to the benzene ring, then the naming is done by numbering the carbon atoms of the benzene ring in such a way that substituents get the lowest possible numbers. For example, 1,2-dinitrobenzene, 1,3-dinitrobenzene, 1,4-dinitrobenzene. In trivial system, ortho-O, meta-M and para-P terms are used as prefixes to represent the relative positions 1, 2, 1, 3 and 1, 4 respectively. For example, ortho-dinitrobenzene, meta-dinitrobenzene, para-dinitrobenzene. Nomenclature of substituted benzene compounds. For more than di-substituted benzene ring, ortho, meta and para cannot be used as prefixes, and the compounds are named by locating the substituents on the benzene ring on the lowest possible number. One substituent of the compound is given number 1, and then the direction of numbering is chosen in such a way that the next substituent gets the lower number. The names of the substituents appear in alphabetical order. For example, we assign number 1 to fluorine so that nitro gets 2 and ethyl gets 4. This compound can be named in alphabetical order as 4-ethyl, 1-fluoro, 2-nitrobenzene. When benzene ring is linked to an alkane with functional group, then the benzene ring is treated as substituent. The term phenyl is used to indicate C6H5. Did you know? Messenger spacecraft of NASA has uncovered evidence that not only does water ice exist on the surface of the planet Mercury, but in many places, this ice appears to be covered in a 10 centimeters thick layer of soot-like organic material. Summary. Let us summarize what we have learnt. Organic chemistry is the study of hydrocarbons and other compounds regarded as derivatives of hydrocarbons. Carbon is a tetravalent compound. Pi bond is formed by the overlapping of p orbitals on adjacent atoms. Organic compounds can be represented by complete, condensed and bond-line structural formulas. In 3D representation, the solid wedge represents a bond projecting from the paper towards the observer, and the dashed wedge represents a bond away from observer. Acyclic compounds are the open chain structures, whereas alicyclic are the organic compounds which are linked together in a ring. Functional group is a specific group of atoms in a molecule responsible for the chemical reactions of that molecule. Nomenclature is a system of naming of organic compounds. In trivial system, ortho, meta and para terms are used as prefixes to represent the relative positions 1, 2, 1, 3 and 1, 4 of a benzene ring respectively.